Hey everybody, my name is Justin Rush, and today we talk about lab number 2. So in the introduction, our objective is using previous data and observations from lab 1. We want to model the charge tapes as evenly distributed charge rods. To accomplish this, we use several fundamental principles such as Coulomb's law and superposition principle. These principles we actively use in this lab to model, and the previous principles we used in the previous labs. And the results of this lab will look something like this, as the white arrow dictates the electric force on tape B, and the green arrow dictates the gravitational force on tape B. So here's a more detailed look on the principles. The key ones are the Coulomb's law, which calculates the electric force, and the superposition principle. Now, this states that the net electric field is equal to the summation of the contributing electric fields at a location, and this also applies to a net electric force. So here's a quick summary of Lab 1. Important observation we found as U-tapes have a positive charge, and a couple of data. The length of the tape used is 0.2 approximately meters, and then the estimated amount of charge in one tape we found as 5.974 times 10 to the negative 9 coulombs. And here's also a quick look of the diagrams from lab 1. And here we get to the meat of this lab. And there's important things to note is first we assume that all U tapes have an evenly distributed charge along the length of the tape. And also when we see the code in lines 62 to 24, we sum the electric fields and then we sum the electric forces. This is important to note. As we can see in these lines, as you can see in the NES 4, we first sum the electric fields and then we sum the electric force to find the net electric force. And here's another look at the output that this code gave us. The red dictates the electric forces that are applied on tape B, and then the white arrow is a summation of those electric forces. And the also important thing to note is the amount of charge required for one tape is different from our previous lab. And as I will talk about this in this question. So the point charge model, our previous lab, we estimated the charge value to be 5.974 times negative 9 coulombs. Whereas this line model, this current lab, we calculated the charge to be 7.09 times 10 to the negative 9 coulombs. A significant change. So why these estimates differ? The quick and easy answer is we calculated the net electric forces differently. In the line charge model, we had multiple electric forces and electric fields, so we had to linearly superpose these electric fields, sum up these electric fields and forces to get the net electric force. But in the point charge model, when we only had single point charge, we only had one external electric field and electric force, which created electric force. So no superposition. The value that is closely related to the real value will most likely be the 7.09 times 10 to the negative 9 coulombs. Because treating the U tapes as a charged rod is more realistic simulation than treating it as a single charged particle located at the center of the tape. So in conclusion, we learned how to calculate the net electric force from multiple electric fields and charged particles. And that is all. Thank you.